Okay, we're just going to practice. So you've got to remember all those things that we had about indefinite integrals before. I'm just going to do a little bit of rewriting here. Namely, instead of x over 2, I'm going to say 1/2 x. And now we just got to remember all those antiderivatives. So, just working term by term. Sine x, we want the antiderivative of sine x. And remember, you're just asking yourself, what has a derivative of positive sine x? What has a derivative of positive sine x? And that's minus cosine x. Then I'll just leave that 6 there. And then the same question I ask myself, what has a derivative of cosine 3x? Well, that's going to be sine 3x with, remember the effect of that 3. Now, if I was differentiating, the chain rule would have me multiply by that 3. So differentiation would have me multiply by that 3, but I'm doing anti-differentiation. I'm doing the antiderivative. And so when I'm anti-differentiation, when I'm finding an antiderivative or doing an integral, instead of multiplying by 3, I will divide by 3. Then on the next one, same thing. Ask yourself, what has a derivative of secant 1/2 x, tangent 1/2 x, or just for now, what has a derivative of secant tangent? Well, secant has a derivative of secant tangent. Your angles, your arguments never change, so still 1/2 x, but then the effect of that 1/2. And the same thing as over here. The effect of the 3 was to divide by 3 or multiply by 1/3. The effect of that 1/2 is to divide by 1/2, dividing by 1/2, same thing as multiplying by 2. And then this whole thing evaluated from 0 to pi over 3. And let's just clean this up a little bit more. So that's negative cosine x minus 2 sine 3x plus 2 secant 1/2 x, evaluated from 0 to 3. And then remember, you can check this part by differentiation. And like I said, if you got a few moments, you can just visually check these pretty darn quickly. Okay, now doing the evaluation. No plus c, by the way, because plus c's are for indefinite integrals. This is a definite integral, meaning I have those numbers there. Now, in this previous problem, I plugged the upper limit into the entire antiderivative, plugged in the lower limit into the entire antiderivative, and then I subtracted the two values using careful parentheses. And that will always work. Plug into the entire upper limit into the entire antiderivative, lower limit into the entire antiderivative, then subtract using careful parentheses. It's a little easier, at least in my book, a little easier just to work term by term. And so I'm going to work term by term. So doing my evaluation, and I'm even going to do this. Just leave that negative sign out in front. Plug in the upper limit. Plug in the lower limit. And subtract. Just first term, plug in the upper limit, plug in the lower limit, subtract, just leaving that negative sign out in front. Same thing on the neg one. I'm just going to leave that negative 2 out in front. Plug in the upper limit. Plug in the lower limit. And subtract. And then I'm going to drop down because I'm running out of room here. So doing the same thing with the secant, I'm just leave that 2 out in the front. Plug in the upper limit. plug in the lower limit, and subtract. I personally prefer to work term by term. That's just what I like. So now starting to do some evaluation here. Cosine of pi over 3, 1/2. Cosine of 0, 1. Minus 2 times, and then showing all the steps here because it's trig. 3 times pi over 3 would just give me pi, so I'm going to have sine of pi there. Then minus sine of 0, plus 2 times secant of pi over 6, minus secant of 0. And that's going to be 1/2. So 1/2 minus 1 would be negative 1/2, and then I have another negative, so just 1/2 there. Minus 2 times sine of 0 is 0, or sine of pi is 0, and sine of 0 is 0. And then 2 times secant of pi over 6. So let's go down here and figure out what secant of pi over 6 is. Secant of pi over 6 would be 1 over cosine of pi over 6. And cosine of pi over 6 is square root of 3 over 2. And so secant of pi over 6 is 2 over the square root of 3. I can make that a little neater, couldn't I? Then secant of 0 would be 1 over cosine of 0, to be 1 over 1 or 1, so minus 1. So finishing this up, I'm going to have 1/2, that's going to be 0 there. Distributing that 2, that's going to be plus 4 over square root of 3 minus 2. And then 1/2 minus 2. What 2 would be 4/2, so 1/2 minus 4/2 minus 3/2. And there is my answer. You find the antiderivative, you plug in the upper, you plug in the lower, and you subtract. And that's the number I want to see. I do not want to see whatever decimal that happens to be approximately equal to. Do not give me decimals unless I give you decimals. So there's that guy. Okay, another one. Like I said, we're just practicing this today. Just practice, practice, practice. But everything you learned about indefinite integrals, you have to remember to do definite integrals. This is a product and a quotient, product and a fraction. You could not do products and fractions directly when you did antiderivatives, when you did indefinite integration. You had to simplify first. So we got to simplify to a non-product and non-fraction. Now there were some ways to not do that. We did learn about U substitutions, which you can use sometimes, but your first line of defense is if you can simplify, simplify. So we're going to FOIL that out first. So it's going to be 1 to 4. FOILing out the numerator is going to give me x plus 12 square root of x plus 36 all over x squared dx. Remember, all I did there was FOIL out the square root of x plus 6. Just FOILed that out, and I'm going to get x plus 12 square root of x plus 36. One term in the denominator, and we learned long ago that the easiest way to handle one term in the denominator was to split that up. Then continue to simplify. Remembering that when we did antiderivatives, there was one fraction we liked. Well, I guess there were a couple fractions I like. But one fraction I really liked when I was doing antiderivatives was 1 over x. So x over x squared, I'm going to simplify to 1 over x. But on the next guy, I'm going to take my exponents here. I didn't do a good job of circling those things. Let's try making that look a little prettier. So x to the 1/2. I'm going to take my exponents and I'm going to subtract them, and so that's going to be x to the -3/2, because exponents are easy to work with in calculus, most exponents. Didn't do that with this guy because that's the one fraction we like to keep the way it is. And then that's 36x to the -2 dx. And now it's ready to integrate. And so again, I just asked myself the question, what has a derivative of? What has a derivative of the 1/x? And that's the natural log of x. If you wanted to be really perfect, you'd slap absolute value around it. I'm not going to worry too much about that in this particular case because I'm on the interval from 1 to 4. The absolute value is irrelevant anyway. Over here, increase the exponent by 1. So that's -3/2 plus 1. Multiply by the reciprocal of the new exponent. And same thing on the end. Increase the exponent by 1. Multiply by the reciprocal of the new exponent. Evaluate it from 1 to 4. And let's just clean that up a little bit. So that's the natural log of x minus 6 over the square root of x, except it's not going to be minus 6, it's going to be minus 24. Minus 36 over x, evaluated from 1 to 4. And remember, this part right here checks by differentiation, but it would only check back to this step right here. It's not going to check all the way back to the original problem clear up here. It only checks back to right here. But now I've had my antiderivative, so now I plug in the upper limit, plug in the lower limit, and subtract. And we're going to avoid a really common mistake here. Working with the natural log of x, I plug in each number separately. So it's the natural log of 4 minus the natural log of 1. Not the natural log of the quantity 4 minus 1. Each number separately. Then minus parentheses, plug in the upper limit, plug in the lower limit, and subtract. Parentheses, because I had that minus sign out in front. And the same thing on the end. Plug in the upper limit, plug in the lower limit, subtract. And like I said, I personally just prefer to work term by term. So I just do each term individually. You could also plug 4 into everybody, plug 1 in everybody, and then subtract those two values. And so I get natural log of 4 minus 0. Natural log of 1 is 0. Minus the quantity, that's going to be 24 divided by 2 for 12. Minus 24, then minus 9 minus 36. And so natural log of 4. The 0 is going to go away. That's going to be minus 12, but then I have a negative, so plus 12. And what, that's going to be negative 27 there. 9 minus 36 is negative 27, so then that's going to be plus 27, which gives me natural log of 4 plus 39. And there's my answer. Now, frankly, the arithmetic on the end is not the point. And so as long as I see a good attempt getting to here, the rest of the arithmetic is not the point. And if you make a small little arithmetic mistake, I won't care. Unless it's trigonometry, then I'm checking everything if it's trigonometry. But the arithmetic is not the point. You have to be able to get to here correctly. The rest of the arithmetic, not the point. Don't worry too much about it. And that's the end of this video.